A, B and C are points on the circumference of a circle with the centre O. We've been told that the angle ACB is equal to 74, which is here. We've been asked to calculate the value of x, and we must state any angle property of a circle that you use. This means that there's a mark available for us explaining which rule we've used of circle theorems to get our answer. You must show all your work in. So the first one which jumps out at us here is that angle AOB here is going to be twice the size of angle ACB. Now we need to work this out and give as close to a reason as possible for it. And it doesn't matter if you use unambiguous language, you'll still get that mark, but just be careful, because if you just say it's twice 74, it will be a 0 for the explanation. So for angle AOB, we are saying it's going to be 74 times 2, which gives us 148 degrees. Now the reason for that, there's a really fancy reason which I'm sure you'll struggle to remember, but if you can get as close to this language as possible, you'll be okay. We're saying that the angle subtended by an arc at the centre is twice the angle subtended at the circumference. Okay, so that's a really long, complicated explanation, but as long as you can try and use as much of that language as possible and get as close to that answer as possible, you'll be okay. So the next stage now, we still haven't found x. So the next thing I'm thinking is that this distance from A to B is a radius, and this distance from A to O is also a radius. So I've actually got an isosceles triangle. So I now need to use my knowledge of isosceles triangles to work out x. I know that if these two sides are the same, well then these two angles are also the same. So the first thing I'm going to do is take 148 away from 180. So I'm just going to quickly work this out to be 32 degrees. So this angle here and this angle here would add up to 32 degrees. So now I need to share that 32 between the two sides, which gives me 16. So x equals 16 degrees.